So I'm going to assume you're the hardcore. Come back for all the nitty-gritty stuff. So don't hold your questions till the end. Ask questions as we go. This is roadmaps are always kind of a working document, and this is no exception. I'm going to kind of stay at a high level so as not to bombard you with details. But if you have any questions about, does that include working on this or that, or I think you ought to also include this or that, please ask them. Also, I'm not just going to walk through a roadmap. I'm going to try to give you a sense of the processes we have. We do produce releases every 4 months, and just a little insight into how all of that works, because this roadmap is all about bringing technology into a release that we can then distribute and everyone can take advantage of it and turn around and obviously improve it. So I'm going to start there and talk a little bit about the reference implementation. That is the anchor to everything that we're doing. It's the gravitational pull that hopefully all the work is moving towards. We have a 3 times a year, 4-month cadence. January, May, September. We shoot for the middle of the month. Might be the last half of the month. We just released 4.0 a few weeks ago, and then obviously there's mid-cycle support branches, fixing bugs and so on. But we also then have, and we have not done this before, but it will happen in a few weeks, we will have a mid-cycle service patch, which means it will still be 4.0, and it will still run all the things it ran before, but now eChord will also run, or mChord will also run. So we will augment the release with another set of services and service profiles that run on that same platform. Which sort of begs the question, what's in a release? And this is an evolving thing. The very first release that we had, 1.0, was pretty tightly integrated Rchord, and we've been slowly but surely isolating the platform and making Rchord one of many solutions you can build or profiles you can build on Chord. So the platform, each release includes the platform. That's been a fairly static set, includes XOS, the build system, ONUS, some of the ONUS apps, the Fabric management app, and the VTN app, plus OpenStack. That's going to change because the platform will soon include Kubernetes. So it'll be a set of services that will control the network and the compute as a foundation, and then that sort of knitted together by XOS, then with service profiles running on top of that. And again, every release, it's not as though a release is a particular solution. A release is a combination, a set of solutions, and each release then has a blessed or official set of profiles that come with it. To date, there's been just one profile, which is the Rchord profile. But as I was indicating, additional solutions, additional profiles will be coming out in the 4.1 release pretty soon. That's the plan, anyway. All of this is moving towards a distribution model. If you're wondering why we're at 4.0 after only a year, and I indicated yesterday that you really should think of it as a 1.0 in terms of maturity, it was in fact the case that the interfaces were changing as fast as we were doing releases. So by the standard version numbering, every release was a different version, so 1.2, 3. And so on. But I think we're at a point that a lot of the core interfaces are relatively stable. Let's call that the 4.0 interfaces. But we'll keep producing distributions, and we're probably just, for the time being, until we come up with something better, just number them sequentially 5, 6, 7, 8, 9, 10, one every 4 months. But the individual components that get combined into a particular distribution will then be versioned separately. That's already happening to a large extent, but we're just going to try to be a little bit more rigorous with that. Okay, so that's kind of an overview of the way we think about the reference implementation and the processes that go behind the releases of that. This is the recent past and the very, very, very near-term future. What basically happened is we did the 1.0 release a little over a year ago, and it included Rchord. And we've been doing 2.0, 3.0, and so on subsequently. But what essentially happened is that 1.0 almost immediately forked, And the eChord team and the mChord team went off and started to bring mChord specific services and eChord specific services into that original platform. And they were doing a sequence of POCs, proofs of concepts, demos, getting a lot of traction and interest in it. But as hard as they tried, they kept integrating upgrades that came along from the 2.0 release and the 3.0 release. But unfortunately, the platform was moving at such a rapid pace they could never catch up. And that's not eChord and mChord's fault. It's the fact that the platform was just changing so rapidly. So as soon as they would get caught up with the latest release, we were putting out another one. Where we are now is that since the 4.0 release, there was now a target, and the eChord and mChord teams are now rapidly working with the platform team, bringing those all into alignment, and that 4.1 release will be the point at which they come together. Now, I'm hopeful that as of 4.1, all new innovation that happens at eChord, mChord, and rChord will all be part of that main release. And so when we do release 5.0, 6.0, it'll come with a wide set of service profiles. And we can kind of maybe temporarily, of course, there's always going to be experimental work that happens that won't necessarily have the latest stuff in it, but hopefully it won't get so far away that it's a year before it comes back in. You'll see that the question mark on mChord, there is so much going on in mChord that we just haven't talked through or walked through the exact timing as to when all of that will come back in. But hopefully it'll be by 5.0 or shortly thereafter. Maybe there'll be a 5.1 after that. So the other thing that happened is that Volta forked off as a pretty independent, almost completely independent standalone project. And it is proceeding, and it's now producing a subcomponent that we will be bringing back into the mainline release. And it will be part of rChord. We don't have exact timing of that. I've speculatively put it out at 5.0. It very well could go a little after that. Yeah.
Will you actually be part of rChord, or is rChord going to be dependent on it? In other words, is Volta going to be, in your opinion, is Volta going to remain have an independent project?
Yes.
rChord just delivering?
Yes. That's a solid line. It will be continued to be independent. And interestingly, I purposely put mChord and eChord up here and Volta down there because they're two different things. Volta is a subsystem, like ONUS is a subsystem. It's a self-contained, its own release cadence, and it's a subsystem like OpenStack, others that we don't have anything to do with except use them, that we will continue to track and bring in. eChord and mChord are different. They are combinations of services that run on that platform. Now, they could potentially become their own independent distributions. There's always the possibility that there are other distributions. But for the foreseeable future, we will just release multiple solutions, multiple profiles on each reference implementation. David?
Would it make sense to take Volta then as a project out of kind of the quote-unquote open core repo and start then kind of its own individual?
Interesting question as to what, if you didn't hear, give it more independence, standalone, doesn't be part of the repo. So it's right now leveraging some infrastructure. We should talk about bringing it out. It possibly, I'm just speculating, it could be that you took Volta to the Linux Foundation and it would be another standalone project. It could have for all practical purposes, it's behaving that way because it has its own TST. And in the abstract, all of these things have their own TST, except they're very, very informal. But we certainly could formalize that. At that point, I guess you would think of the chord reference implementation as being one of the consumers of that project. So this is, by the way, I think one of the strongest powers of what's going on with this community and this ecosystem is when we started, Volta was just this little tiny annoying piece of code that Ali had to write because otherwise he couldn't control the non-OpenFlow compliant OLT device. And it's now spun out into its own pretty much independent project with lots of moving parts to it, its own release schedule and so on. And yet it fits in here. And as part of this ecosystem, I think gains value from being included with the rest of RCord, I would argue. And in the same way, when you heard Tom's talk yesterday, Chord was spun off of Onos at one point. In fact, I wouldn't be at all surprised to see MChord take on a life of its own, because there's such a large amount of independent activity going around it, because we're inventing, that community's reinventing 5G. One could imagine something like that happening. And yet, all of these things reinforce each other and build on each other. I think that's a real strength. Okay, so one last, just in case you missed the animation. Somewhere past 5.0, and again, we haven't worked out the schedule for this, is the multi-access edge cloud, or multi-access edge, which is once we've brought the MChord portfolio, the service profile, the eChord service profile, and the RChord service profile all running on the same platform, we can release a fourth service profile that is the combination of all of them. And that is the multi-access edge. That is one of the main objectives that the community has right now. When that first comes together, in theory, once we have all of them running on the same platform, it should just be a matter of configuration. None of us think it's going to be quite that easy, because in the data plane, we believe there are probably some subtle inconsistencies with assumptions these different, these different verticals have been making. But we think we're going to be really, really close. So sometime in the not too distant future, maybe hypothetically a 5.1 mid-cycle, we will be able to say, here's a couple of these running together, wrapped up in the entire system. We've certainly had proofs of concept from others like DT on that front. That's great, but we will be able to release it back to the community as part of this entire package, which is where we want to get to. By the way, just because you have all three of these profiles running simultaneously doesn't mean that you're finished. The real thing that we're after here is that they start to intermingle and the boundaries between them break down and become invisible, because they're leveraging common services as opposed to having their own sequence of services. All right, so that's the roadmap in the near term. This is now, I'm gonna broaden it a little bit and talk about priorities in general. And again, this is all building on where we've gotten to so far. So the 4.0 release, I think it did two main things. The first thing it did was it stabilized the interface that service developers code to. So it is now hopefully not quicksand underneath you moving, and it's actually a pretty good interface, and a pretty minimal amount of things as a service developer you have to do to get your service onboarded into Chord. So the next thing to do, quite obviously, is let's build out a larger service portfolio. And we have some specific things that that will take us to that goal. The first one I've already been talking about, which is simply to upgrade all the current REM Chord services to use that API and to be part of that 4.1 release. So that one's already well in progress and getting close to done. The second one I also hinted at, which is to integrate the new work happening at the access device. This is both in the MChord case of XRAN and the RChord case of Volta, that those new innovative access capabilities be brought into the fold as well. So it's not just the services, it's the full disaggregation and SDNization of the access that we want to include. And that then is arguably what gets us at that multi-access edge. Another thing that's going to happen, and you'll see this in a little bit more detail in a couple of minutes, but OpenStack has been the go-to compute as a service capability in Chord up to this point. And it's still the case that apparently 95% of all DNFs run in VMs. But we have been spinning up containers for a variety of reasons. We've been managing them by hand without the help of a container management system like Kubernetes. But clearly we want to get Kubernetes as a first-class piece of the platform. Once it is, then you'll have the option of choosing Kubernetes. I shouldn't just say Kubernetes. There's actually an effort underway right now to do the same thing with Docker Swarm. So that's a community contribution still being integrated, but Docker Swarm, Kubernetes, OpenStack, all as sources of VMs and containers for your VNFs. Now, as soon as Kubernetes is there, it opens the door for every microservice that's out there available as a Docker image to be spun up on Cord. And I think that's a really exciting thing. And if I could suggest one way to get involved in Cord, and you're looking for huge impact, minimal overhead, it would be take an existing open source microservice and bring it up on Cord. Pick your favorite one.
Why only open source? Why not proprietary?
Because there are so many open source. So Guru's making the point, which is a very good one, that you do not have to open source your VNF to bring it up on Cord. Thank you. But if you don't happen to have a proprietary VNF in your back pocket and you wanted to bring up a service, there's a ton of open source microservices that you could start with. Now, to Guru's point, we very, very, very much welcome proprietary ones as well. We've had a little experience with that. In the very first release of Cord, we had an Akamai proprietary CDN running as a VNF. It ran in a virtual machine. It ran in a KVM virtual machine. We happened to have a experimental use relationship with Akamai, and it worked out great. You could arrange the same thing. You could bring up an instance of Cord, and you could actually get your proprietary VNF included in a distribution if it ran through all the tests without giving away the source code for it. We would just, in the official release, it would say, your proprietary VNF, follow this link for an evaluation license or something like that. We have to work out the details, but clearly you can do it for yourself and try it out. But we'd really like those proprietary VNFs back into Cord as well, available to the rest of the community to try out. Of course, it's a business arrangement with you as to who you would want to let them experiment with your VNF, but that's another issue.
What brand of equipment will be supporting the constraint?
Okay, so you want to take this?
So far,
Wait a second. So let me get the mic, because all of the team leads are here, I think, and we'll be able to talk to very specific.
If people want to ask questions, the mics on the side are live.
Go ahead.
So there is going to be an upcoming talk on extract where we can talk more in detail about this. But so far, for the NWCA
You need to switch it on.
proof of concept. Okay, is it better? All right. So in the San Francisco NWC, we partnered with Radisys, and it was the Radisys eNote B that was extract compliant, and that interface with the ONOS extract application. And like I said, there's going to be an entire talk dedicated to extract, so there we can talk more in detail about it.
Okay, so Kubernetes, microservices. We would like to onboard VNFs from other sources. So we're looking for opportunities, if you're involved with ONAP, for example, to have ONAP treat Cord as yet another cloud, and to provision and instantiate a VNF through that interface. I'm going to come back to ONAP because that's clearly an important aspect of the roadmap. And of course, the more services we onboard, we believe that we will just get smarter and smarter. That's our motto, is we don't know everything there is to know yet. And so we will just continue to streamline the onboarding process. If you want to try today's onboarding process out, there are a sequence of 3 hands-on tutorials where you'll get your own virtual deployment of Cord, and you'll get a little example VNF, and you'll bring it up and go through that process. So look for that on the schedule. We know there's still streamlining to be done, but hopefully you'll see that it's getting close. All right, so that's the first big priority. The second big priority is, again, to build on a major bit of work that went into 4.0, which is the refactored build system. When we were working on the build system, we were really focused on improving the developer workflow. As a service developer or a developer of the core system itself, you would really like nice, tight development loops so that you can get your work done efficiently. Chord is this integrated whole, and so honing that down so that you can work on subsystems of Chord in a way that when you're done working on your component, there's some decent chance that when you try to integrate it back in, it'll actually work. So a lot of work went into that. And hopefully you heard the build system, the build system yesterday. Well, the build system now, because it's been refactored, gives us a lot of flexibility in how you build a Chord. And so we want to take advantage of that and improve what the operator workflow or the operator experience. So first and foremost, there's still a manual step, a manual configuration step in bringing up a physical pod having to do with configuring the switching fabric. We want to fix that, so that's clearly high on the list. We want to make it easy to specify and change profiles independent of everything else. It's still the case that you have to go into the core platform install. Independently, each profile gets its own little space in there, but it's kind of lumped in with the entire Chord build. We want to just refactor and pull that out so you can work on your profile, which is a set of services. So it's as though you are a system integrator. Not everybody's a service developer. Some people are system integrators, and we want to make that process a little bit easier. And change just means that as a pod is up and running, you can dynamically onboard a service. We're within Epsilon of doing that, but there's a little bit of work required to make that. In-service software upgrade is always an issue. In Chord, the Chord controller, which XOS is part of, is operation critical but not mission critical. So the hurdle for making that in-service software upgrade is a lower one to clear, but we need to demonstrate that we can do that. Some of the subsystems are going to be more critical. Kubernetes is going to help us a lot in managing restart and so on of microservices. ONOS has its own independent task to do in-service software upgrade, and we'll need that to happen to take advantage of it. The final bullet, if you can see to the bottom, is when we bring up a pod today, we assume we own all the hardware. It's in the rack. But there's plenty of deployment opportunities out there where the operator already has a Kubernetes cluster, they already have an OpenStack cluster, and we need to do some work so that we can leverage that rather than assume that Chord starts at bare metal.
Larry, on that bit, the operator might also have their own switching fabric on top of this.
Yeah.
And so the fabric as a service needs to be able to plug both of those capabilities.
Yeah, good point, good point. So that track of thought grows increasingly challenging to take care of all of those. So we'll probably try to clear a low hurdle first, but you're absolutely right. So the components, an interesting question. The components of Chord are relatively independent and loosely coupled. And so changing out, I'll just take it as an example, the VTN, which is managing the virtual network overlays, and replacing it with something else because you already had something else is an interesting problem and one that we would welcome people to work on and contribute back. There's a ton of those that we have not, even though, I'm going to put it this way, even though we have tried to disaggregate and keep these things loosely coupled, because there's only one of certain things, like OpenStack or VTN, we don't know for sure that we've done our job right there until we actually do a second one. Right, that's approaching it from a priority point of view. Another way of looking at this is, what are the drivers? What is it we hope to deliver in terms of a demonstration that we've actually accomplished what we set out to accomplish? And there are, in my mind, 3 drivers. The first driver is multi-access edge cloud. So you can think of these drivers in principle as having come down from the use case steering team. That organization is just now starting up, but these are 3 targets, 3 deliverables, 3 use cases that we've been hearing a lot about. So the first one is multi-access edge. So again, I've been talking about that, but that is clearly it's always good to have a target you're shooting for because that forces you to focus and try to get something accomplished in a time frame. And so bringing the REM profiles together plus Volta and XRAN in the next couple of months is something that we absolutely plan to demonstrate. The second target, I talked just a little bit about yesterday, but it's related to Volta as well, which is we have the ability to scale cord down so that instead of giving you an entire service graph worth of functionality, it gives you one service, which is the virtual OLT service and everything that depends on. So that requires including Volta. This is basically, the demo target is, can you scale cord down? So it includes the OLT support, or Volta. It would include or exclude OpenStack and include instead Kubernetes, so we would have scaled down the management overhead required. And it would include enough management to support subscribers who would then connect to that edge device. And there's a project, I forget if I mentioned this yesterday, just starting up called Awesome, O-S-A-M, pronounced Awesome, which is open source access manager. So if you were to scale down cord so that it just gave you access as a service, then you would want to manage that from both let's say an ONAP perspective and from the subscriber perspective, which is, I talked about that picture a little bit yesterday. So that's a second high-level deliverable that we're working towards. The third one is just a demonstration of how to integrate cord and ONAP. And here, the target is a little fuzzier because we don't fully understand what's involved, but what we have are 3 use cases that we're pursuing. One use case is the awesome use case I just described. Can you use ONAP to manage cord if cord is downsized to just give you access as a service? The second use case is eCord with multiple pods connected by a backbone network, which is in ONAP's wheelhouse, right? This is now a global orchestration between ingress pod, go across the backbone, egress pod. So I've got at least 3 things I'm trying to coordinate. As I indicated, the eCord demo that works today has a cord-based global thing because we needed something there, but we want to try to replace that with ONAP. And in particular, this is going to stress the cord MSO integration, the orchestration piece of it. It won't necessarily stress all dimensions of it, but at least that's the focus. The third use case is a lot of activity going on right now in ACORD, Analytics for Cord. The monitoring service and DCAE from ONAP are really quite well aligned. And it's a matter of making sure that the interfaces work. And so we're going to hear about that a little bit in the ACORD session, but ONAP is expecting VES, which is Virtual Event Stream. VNF Event Stream. There was a virtual in there somewhere. All right, so VNF Event Stream as the interface for getting analytics data or monitoring data out of cord. And there's also a notion of there being a hierarchy of collectors. And so the cord collector that already is there in ACORD would be an element of that hierarchy. And so we think that's actually bringing elements of ONAP into cord, leveraging what's also already in cord, just because you've supported the same interfaces. So again, those are 3 use cases that for today are being pursued semi-independently, because we're going to boil the ocean if we try to do this all at once, and hopefully downstream somewhere they'll come back together. Okay, questions about any of that before I move on? All right, so I'm going to get to the bulleted list of roadmap items in a minute, but I wanted to first talk about what's the point? Why are we doing this? And I think one of the key things that we see is that there is a lot of activity going on in the proof of concept space. There are lots of demos, proofs of concept at ONS, at MWC. We're seeing lots of possibilities with cord. The question is, what is the process by which you get that into field trials? Because that's where we all want to get to, because we believe there's revenue just on the other side of field trials. Okay, so I'm not trying to take you to the business argument just here. I'm focused on the technical aspects of it. All right, this is a challenging thing to do. Let me give you a perspective on a way that ONF is trying to catalyze this. This is not something ONF can do by itself. This is all ONF can do is try to catalyze the community to do this. And so this is one way of thinking about it. What are proofs of concept? They tend to be narrow. There's a proof of concept around network slicing and MCORD. Very specific capability, a very specific feature or function. And to get that to push the edge of the envelope really far on that one point, you kind of ignore some of the things around the edge. You just can't take care of everything at once. You're trying to push one point forward. And it's also about possibilities, right? We've all been involved in proofs of concept where maybe there was a little hand waving going on behind the curtain, right? So we all know what this is about. On the other end of the spectrum, field trials are very operator specific. If you're going to drop a field trial into an operator's environment, then they're going to dictate this is how you interface with this is how you interface with that, and so on. That's about reality, right? The truth of on the ground as to how these things integrate. That's a big gap, right? At the bottom, it's reality, and you can't have, maybe you can get started with a quarter of a solution, but you really got to answer all 18 questions, right, on the RFQ. How are you going to do this? How are you going to do that? And you're very narrow and very specific at the top. Well, this is now a pitch for what we're trying to do, which is what we have is a reference implementation. And it's curated by the TST, so that is a place you really want to get involved if you haven't yet. And that's basically, here's a set of services. Do they meet the criteria for including in a release? Yes or no? QA's trying to test them. We're trying to determine if they actually fit and would interoperate with other things. It's an integrated system. You go to the right directory in the build, you configure what you want, and you type go, and you get that configuration. So we're trying to eliminate all the backdoor stuff that goes on. This is the point of entry for configuring the reference implementation to crank out one particular solution. And it's supported. We don't have a lot of history supporting this yet, and so the more VNFs we get in here, it's going to be a broader requirement on the support for that. But if we've integrated it and tested it and stamped it as part of 4.0, then the TST says we are willing to, with the help of the community, support that release. All right, those are pretty significant things. The challenge then is, as a very broad community, what I would argue is that the thing to focus on is how do I get these proofs of concept? I mean, you can do it and walk away from it. That's always happened. But if you could get that proof of concept integrated into the reference implementation, then that's a good thing. And everyone involved in CORD and cranking out reference implementations is vested in helping get that done. Right? So there's how do you onboard a service? There's a tutorial. Between Slack and the email, there are places to ask questions. And through Garrett, you get to submit your proposed changes, and those code changes are reviewed. So there's a process in place to help make that happen. Once it's released as part of the reference implementation, then it needs to be customized for any particular deployment. And the ONF team has been involved in in some of that, but it just simply does not have the resources to do that, any more than it had the resources to do every imaginable proof of concept. So this is where the community steps up again and says, I see an opportunity in this particular carrier. If I could take that reference implementation and customize it in some way or another to make it fit in this specific deployment field trial, then I've got reason to do that. And we've seen that certainly with some of the things that have been happening, particularly with Voltham. All right, so this is the model for how we can, as a community, make progress. Tons of activity get reduced to a common intermediate place from which lots of different things can happen. So what's the alternative? The alternative is that you do a proof of concept, and because of a relationship you have with a carrier, you go in and do a field trial. And that is absolutely going to happen. I understand. But as a community, there's an alternative, which is if you would instead, or in addition to that, taking advantage of that opportunity, you brought that proof of concept into the reference implementation, then you get an amplification effect, right? Because it's now available to all the other proofs of concept that are going on, and they can leverage that feature. And it's available not just to the service provider that you had a relationship with, but it's available to all of them. There is a lot of work involved in bringing the proof of concept and that new feature into the reference implementation, and there's a lot of work involved in then taking that common representation and going off and doing something else with it. But that's the way to get the amplification and amplifier out of it. All right, a way of thinking about it, and a little pitch for, it's really important that, I know lots and lots of people have downloaded Chord, and based on the questions being asked on email and Slack, there's been a lot of people bringing up pods. It would be great to also, just know about those, because right now everyone's somebody.gmail, and it's kind of hard to tell who's doing what. But second, look for opportunities to bring that code back in, because there's real value in doing that. OK. Now, with, actually eating up the hour pretty well. So let me fairly quickly walk through a little bit more detail on the roadmap. And this is fairly high level, and go to each of the individual sessions and you'll learn more. But I wanted to give you a sense of it. So now I'm walking through the components. First component is the build system. As I've indicated, there's some things that yet need to be done to improve the developer development workflow, and that they quite often involve better debugging and diagnostic support. And we're trying to decouple the service profiles so that you can build a profile without having to be quite so dependent on the entire platform. And then from improving the operator workflow, the install process still has places. It's a fairly narrow path that you have to follow. We're just trying to make that more robust. Kubernetes is going to be part of that, and it's going to help. Flexibility in, again, this is a little bit repetitive of some of the high priorities that you saw before, but it's part of the build system that I can use my own OpenStack instead of having to install it from scratch. And as I've indicated, that we can swap in and out container management, VM management, and hopefully both at the same time. We need to discover the configuration of the fabric so that we can automatically provision it and configure it as opposed to having a manual step in there. And we need to support, if you can't see at the very bottom, database migration. That's been on the to-do list, but database migration in the sense of if I upgrade the data model, I need to migrate the schema of the database. Part of what I just talked about was Kubernetes, so looking at that a little bit more closely, so you can think of this as part of the platform/build system. We want to both use Kubernetes as a foundation for deploying Chord itself. So OpenStack, XOS, ONAS, and all of its apps get deployed as containers, but can we deploy them as containers managed by Kubernetes? But we also then want to use Kubernetes in support of VNFs. So these aren't going to necessarily be the same VNFs that you were running in KVM, but we have a whole wide area of opportunity with microservices to bring them up in Kubernetes. And I think over time, we're going to see more VNFs that will be container friendly as well. The challenge there is interoperating between, we've set it out as a goal, so therefore it becomes a challenge of interoperating between KVM and Docker. And there's a container VM session later today or tomorrow, and you'll go down a little bit of detail as to what's involved there. There's some interfaces there that are going to make plugins available that should help on that. And the final piece of this is we want to demonstrate a variant of Chord that does not have OpenStack, just to show that we can do it with just containers, that we've actually done the job of decoupling all of these things so you don't have hidden dependencies in there. And so that's sometimes called light and write Chord. Turning to XOS specifically, there's some things that need to be done for developers. I don't know that there's dynamic service onboarding is one of them, and statically checking that your onboard recipe is right so that you don't have to actually go through the process of building it and testing it, which is a little bit more time consuming. This is some low-hanging fruit that's going to pay big dividends as well. We think there's some more cases that we can auto-generate code that will make your life a little easier. And there's a couple of performance issues, both the API, the gRPC API support for Python isn't the best in the world. So there's a little performance hit there that needs some attention. And synchronizer performance, especially as they scale up. We would just need to demonstrate that that scales. There's also an opportunity to auto-generate some test cases that we'll take advantage of. That's support for developers, support for deployment engineers or operators, better support for tracing and debugging, diagnostic. Database migration comes in here again. It's also a value to do the dynamic service onboarding. There's some enforcement of policies, models that just aren't checked to make sure that you have a valid configuration. And there's some graphical front-end work that needs to be done just to clean up the service graph so that you can make more sense of it. Trellis, dual homing. This release refers to ONAS fixes for some known issues. Pseudo-wire support is important in eChord. And I think it will be important in other cases that we can connect the outgoing side of chord to whatever is on the outside with pseudo-wires. IPv6 needs additional features are required. And then there's always more hardware coming down the pike and support for that. So I don't, has the roadmaps already happened for Trellis? Or is that still coming? Tomorrow, okay. So there's a session that you can go hear more about that roadmap for Trellis. QA, always working on QA. These are very generic. There's a QA session. Please go attend that if you want to know more. We could really, really, really use help here because there's a lot to do. As we bring mChord and eChord in, we need to ramp up the tests that we have available to run against them to bring them on par with what we do for our chord. And there's just more tests that are needed just broadly across the system. Regression tests, end-to-end continuous integration tests for particular subsystems that get brought up and code checked in. And the big one at the bottom is performance testing. There's very minimal performance testing right now. And we need to establish the baseline so we know what needs to be improved, and then we can demonstrate and measure how much we're improving it. Our chord. The big thing is, again, integrating Volta into our chord. There will be continued work in Volta. This is really short-changing everything that's going on in Volta, but again, that you can go attend the Volta sessions to learn more of that detail. One of the big things here is this item, which is exploring how much functionality can be moved out of VMs and containers and into the data path, the data plane. And so P4 comes into play because it's going to give us even more capability. So it's kind of obscure in the way that this got written down, but activity around P4 is ramping up both in our chord and in mChord as well. And of course, this is going to be part of this chord-wide effort to build a multi-access edge. The eChord roadmap, services, services, services. It's a little bit bare bones now. It's giving you the fast path, but we want to also spin up VNFs that enterprises can take advantage of. ONAP integration, as I said before, eChord is one of our prime use cases for exploring the ONAP chord integration. Again, it's part of the multi-access edge, and there's other devices that the eChord team is looking at it, at integrating it on the on-premises equipment, the CPE. mChord. I don't have enough room on any finite number of slides to say everything going on in eChord, so let me give you the following summary. Integrating the XRun enhancements into the chord platform, I've talked about that before. We want that to be part of the standard release. Expanding the open source availability of the EPC. So the 4.1 release is going to have some open source in it, but there's still more to add to that over time, and we're expecting that to happen in the next year. The last bullet is what mChord is all about in some sense. Continued SDNization / disaggregation of 3GPP. That's a huge challenge, and go see the mChord session to learn more, but I'm going to give you a little bit of a roadmap. This is the way I think about what's going on in mChord. This is mChord for dummies. So this is, I had to do this for my own sake. This is about disaggregation. So we have the RAN and we have the core. And a lot of what MCORD is about is figuring out what functionality goes on which side of that line. XRAN draws the line in one particular place. Programmable RAN draws the line in another place. Those are two options, and maybe they could exist simultaneously, but it's an exercise in figuring out what happens on the RAN and what happens back in the core. Okay, that's a fundamental part of what eCord is about. In the other dimension, MCORD is about taking 3GPP and disaggregating and splitting the control plane from, not the data plane, from the user plane. So above the line is control of 3GPP, and below is the user plane for 3GPP. Everything that's being released in the upcoming 4.1 release of MCORD is not everything. That's a large part of it. And so there's been a lot of disaggregation there. When we started, the EPC was one big lumpy thing. The MCORD team has already disaggregated it. And some pieces go above the line because they're control, and some pieces go below the line because they're user plane. But that's just the next step. The step beyond that, which is where the exciting work that's coming down the pike is going to happen, is you go into the user plane, which is now 3GPP user plane, and you subdivide that into the network control plane and the network data plane. So this now becomes an exercise in disaggregation and SDNization of the user plane of 3GPP into, now using network SDN terminology, the control plane and the data plane. This then is where moving functionality down to the data plane, the network data plane, will be leveraging P4. So it's an exercise in disaggregation. As soon as you disaggregate, you've got to figure out where all the boxes go. Is it a control box? Is it a data box? And if it's a data plane box, is it a data plane box that lives on an x86, or is it a data plane box that lives on a switch? All right, that's my roadmap for MCORD. Go to the MCORD session, which I think is at 11 o'clock, and hear a lot more detail about that. Finally, ACORD, analytics for roadmap, analytics for CORD, upgrade all these ACORD services to the 4.1 release. Everything I've been saying for MR and eCORD, we have to do for ACORD as well. There is now work on integrating monitoring data for P4 into CORD. I've already talked about integrating ACORD as a test case, a use case with ONAP. So that's, again, a high priority. And making sure that we're using all the right interfaces so that we're interoperable. I think this is going to end up with not just one collector in CORD, but a hierarchy of collectors. That's the model that DCAE has, and it's consistent with what we have in ACORD, but we just haven't exercised that yet. And so that's going to be on the roadmap going forward. And again, there is an ACORD session coming up later today or tomorrow.
Is there anybody from China, Unicom here, Wei Zhao? So yesterday I heard a very inspiring use case for CORD from China Unicom when they said they are partnering more and more with OTT providers, and they are looking at CORD as a way to do what they call network edge as a service. That is, you can imagine that the CORD is deployed at the edge of the network, and then you can take a part of that platform and make it available to OTT providers, and those OTT providers can offer their services on top of the CORD platform on side by side with whatever the telco providers are offering. I think that is a use case scenario that is very inspiring and can be very exciting to consider. And I hope it will get on the roadmap somehow.
Good, good. That would be a great use case. It would stress multi-tenancy, which CORD's designed to support, and so it's well positioned to do that, but it would be good to have a driver for that. Okay, so why don't we get the full TST up here and we'll move on.